sparse matrix, both by reading the matrix first and converting it to sparse, and then reading the matrix directly in the sparse notation form. After that, we had considered the addition of two sparse matrices, and I suppose quite a few of you have some problem related to that because you have forgotten something that was studied in the first semester as merging of two sorted arrays. There will be two arrays, say array A and array B, which are to be merged, and initially they are present in the ascending manner. So even the resultant array should also be the sorted one. The assignment was there in PL1. You didn't have anything like that. You have not come across sorting or merging at all. Sorting was there, that I know. Merging of two sorted files. Good. Okay, so we'll first of all cover this part and then continue with the sparse. Suppose the values are 2, 3, 7, 11, 26, 29, 35. And the second one has values as 1, 2, then 8, 9, 20, 21. So this is from position 0, 1, 2, 3, 4, 5, 6, in all 7 elements in array A. 0, 1, 2, 3, 4, 5. Let us add one more, say 42. So 8 elements in array A, 6 elements in array B. And we are required to construct array C, which is going to be again a sorted one. This is called as merging. But the merging is interesting when the arrays are sorted. If they are not sorted, in that case you can simply concatenate the two arrays, because then the result also will not be the sorted one. Okay. If you don't have this merging, you have something called as taking the union of two sets. अरे कुठल्या कॉलेज पुणे युनिव्हर्सिटीचा जात ना युनियन ऑफ टू सेट्स वॉज देअर हा नाही काय म्हणताय अरे okay. Now C also will be in the ascending manner, and remember that we will start from position 0 in each one of them. And out of, we will compare these two elements. Out of these two, the one which is smaller, that should be transferred to C, and we should consider the next element in that array. Okay. So in this case, 2 and 1 will be transferred to C, and we will go ahead in array B. Then it is 2 and 2. If they are equal, copy both of them one after the other and increment both. Now consider it with last time's example. This is like K1, this is K2 position, and this is K3. Instead of ABC, consider this as something like SP1, SP2 and SP3. It is going to be logically the same thing. value at position sp1 k1 and value at position sp2 k2, the one which is smaller, that should be copied to sp3 at position k3. So k2 is incremented here, k3 gets incremented. K3 was initially here, it goes to this position. When sp1 k1 is equal to sp2 k2, both the values are 2, then we are putting both the values in array C. K1 gets incremented, K2 also gets incremented. Then it is 8 and 3, 3 will be copied, K1 is incremented. 7 and 8, 7 will be copied, K1 is incremented. Then 8 and 11, 8 will be copied. 9 and 11, 9 will be copied. 11 and 20, 11 will be copied. 20 and 26, 20 will be copied. 21 and 26, 21 will be copied. And then you reach end of array B or sp2. When you reach end of that particular array, then the remaining elements of this array, they should be copied as they are. This is precisely what we were doing last time in addition of sparse matrices. Only thing is, there was a double check, like we were comparing the row numbers as well as column numbers. Here it was only a one value check, one position, not row number, column number. Only K1, K2 positions are to be compared, not dot row and dot column. Okay, how will be the code for this? If K1, instead of K1, K2, K3, if I just use the indexes as I, J, K, and if I say array A has m elements, array B has n elements, and both the arrays are sorted, how do we write the code for it? I will start from 0th position in array A, I will start from 0th position in array B, and of course 0th position where I will write the first element in array C. I will have to check if A of I is first of all equal to, just to compare it with last time's code, if A of I is equal to B of J, if both the elements are equal, then C of K will be A of I. दो बार कॉपी होगा ना, like 2. So copy element from A, copy element from B also. C of K is equal to B of J. Then I plus plus, J plus plus, K plus plus. First part. Else, if A of I is less than B of J, then C of K, copy the smaller A of I, increment I, increment K. And else B of J will be smaller, so C of K will be equal to B of J, J plus plus, K plus plus. Was our comparison of row last time, when the rows are equal, when row number of first one is smaller, when row number of second one is smaller. And you will keep on doing this as long as none of the array gets over, that is while I is less than m and J is less than m. And afterwards there will be two cases, either the first condition is false or the second condition is false, and accordingly you will have to copy that particular array. So it was like while I is less than M, C of k equal to A of I. Now I don't have to compare because copy the remaining elements as they are. So it will be I plus plus k plus plus. Either this loop will be executed or it will be while j is less than n, C of k equal to B of j, j plus plus k plus plus. This will be the code for merging of two sorted arrays, which was the logic behind the addition of two sparse matrices. You were facing problem because you were not knowing the merging of two sorted arrays. Actually, if you have reached sorted, if you go through the syllabus once again, this assignment is there listed in the syllabus. कॉलेज में नहीं पढ़ रहा है इसका मतलब ये नहीं कि सिलेबस में नहीं है. And we should not be sticking to whatever is taught in the college. You should be referring to the syllabus. कॉलेजमध्ये त्यांना जे जमतं ते शिकवतात, त्याचा अर्थ तो सिलेबस आहे असं नाही. आणि सीओपी वगैरे मधल्या मुलींनी असं सांगायचं म्हणजे वाईट वाटतं. रे माझ्या कॉलेजचं हा नाही, म्हणजे कॉम्पवाल्यांनीच विचार करायला पाहिजे. आयटीला होतं कॉम्पला नव्हतं याला काय अर्थ. आयटी वाले बच्चे आहेत अजून, एवढं लक्षात ठेवा. कॉम्पवाले कॉम्प पीपल शुड हॅव द सुपिरियरिटी कॉम्प्लेक्स. शुड. मेक अ नोट. काय बघत बसला माझ्याकडे, संपलं ना. Isha, write semicolon, huh? Not comma. So this while loop ends here. This is the scope of this if, this. If you can't see it over here, you can see on the screen, huh? That will be displayed across. The particular algorithm will work only when the given arrays are sorted. That too will work only when they are in the ascending manner. For descending, you will have to change the particular part in it. Like this, less than should be changed to greater than if they are in the descending. And if the array is not sorted, then you are not sure the arrays, they will get merged actually. Only thing is the sequence is going to be pretty random type. It will appear to be random. Try it. This is capable of merging the two arrays. It will. But there is no logic as which element is picked up. It will just trace this path. As it is, there is a loop, that is till you reach end of one of them. So it will go till the end of one of the array and will copy the remaining array. Resultant will not be again a sorted one. It will be the current two values are compared and smaller is copied. Then let us consider the example for addition of two sparse matrices. So two sparse matrices are given to us. You have the last time's code with you. We are required to follow the steps, the code, and generate sp3. We will be generating sp3. By following that code. Where is initially K1? At 1. Where is K2? Position 1. Where is K3? Position 1. What do we compare? Whether K1 is less than sp1 square bracket 0 dot val. कोड आपके पास है, यहाँ नहीं है. It was while K1 is less than sp1 square bracket 0 dot val and K2 is less than or equal to the actually, and K2 is less than or equal to sp2 square bracket 0 dot val, that is 1 less than 6, less than or equal to 6, and 1 less than or equal to 6 true. Then we check whether sp1 square bracket 0 dot row, sp square bracket k1 dot row equal to sp2 square bracket k2 dot row, whether they are equal. In this case, yes. Then we have a check whether sp1 square bracket k1 dot column, that is 2, is equal to sp2 square bracket k2 dot column. No. Then we have a check sp1 square bracket k1 dot column less than sp2 square bracket k2 dot column. No. That's why copy the element from sp2. What do we copy? We copy row number, we copy column number, we copy value, we increment k2, we increment k3. We again check sp1 square bracket k1 dot row equal to sp2 square bracket k2 dot row. Yes. sp1 square bracket k1 dot column equal to sp2 square bracket k2 dot column? Yes. In that case, copy the row number and column number and copy the addition. 3 minus 1 will be 2, and increment k1, increment k2, increment k3. sp1 square bracket k1 dot row equal to sp2 square bracket k2 dot row? No. sp1 square bracket k1 dot column less than sp2 square bracket k2 dot column? Yes. Copy the element from sp1. 0, 3, minus 1. Increment k1, increment k3. sp1 square bracket k1 dot row equal to sp2 square bracket k2 dot row? Yes. sp1 square bracket k1 dot column equal to sp2 square bracket k2 dot column? No. sp1 square bracket k1 dot column less than sp2 square bracket k2 dot column? Yes. Copy the element from sp1, that is 114. This is k1, k2 again. sp1 square bracket k1 dot row equal to sp2 square bracket k2 dot row? Yes. sp1 square bracket k1 dot column equal to sp2 square bracket k2 dot column? No. sp1 square bracket k2 dot row less than sp2 square bracket k2 dot row? No. Copy element from sp2, 1, 2, 6. Increment k3. sp1 square bracket k1 dot row equal to sp2 square bracket k2 dot row? Yes. sp1 square bracket k1 dot column equal to sp2 square bracket k2 dot column? Yes. Then add 1, 3, addition 0, and yesterday we had written that condition, if value is 0, don't increment k3. In that case, k3 will stay here. ये सब k3 increment हो चुके हैं. k3 will stay there because the value copied is 0. But both of these will get incremented. sp1 square bracket k1 dot row equal to sp2 square bracket k2 dot row? Yes, 2, 2. sp1 square bracket k1 dot column equal to sp2 square bracket k2 dot column? No. sp1 square bracket k1 dot column less than sp2? Yes. Copy this element, but k3 has not incremented, so this will get overwritten. And then k3 will increment. This is what we have seen yesterday. And then sp1 square bracket k1 dot row equal to row? Yes. sp2 square bracket k2 dot row, they are also equal. Addition now can be performed because it is not 0, it is 2, 1, 8. This will get incremented to this position, this will get incremented to out of limit. Then that while ki condition goes false, k1 less than or equal to sp1 square bracket 0 dot val. This has already become 7 now. It is 1, 2, 3, 4, 5, 6 and 7. That condition will be false. We come out. We check whether k1 is less than sp1 or less than or equal to sp1 square bracket 0 dot val. No. We check the second, whether k2 is less than sp2 square bracket 0 dot val. Yes. Copy this. Increment it. Still less or equal, 2, 3, 6. Goes out of limit, we stop. K3 has moved to this position. It was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have said copy the row number, 3 rows, 4 columns, and val will be K3 minus 1, 9. This is how that addition will work. Okay? Make a note if you want. Try to follow the steps. This is the only way by which the algorithm can be checked. Because otherwise, machine will give you some output. And whether it is the required output or not, that you will have to check. These were the two original matrices. This should have been the input actually, because this will get converted to this form. And then the addition, if you see, it should be 9, 0, 2, minus 1, 0, 4, 6, 0, 10, 8, minus 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. Check the contents also. 9, 2, minus 1, 4, 6, 10, 8, minus 5, 6 here. This was the simple assignment in your PL1, addition of two matrices. Why I am giving this? Because when you run the program, this is the input that you should be giving for first one, this is the output, this is second input, and output will appear in that form because you will be printing SP3 only. Good. So we'll go further. With the next part, where we are required to take the transpose. The transpose of the sparse matrix. What is transpose? Interchanging the rows and columns. The one which is earlier present as row will become column. Truly speaking, the transpose of this matrix will be 436, 203, 30 minus 1, 114, 317, 02, 10 and 125. Should be treated as the transpose, no? Because row number has become column number has become row number. Number of rows, where it was 3 rows 4 columns, now it is 4 rows 3 columns. Positional relation is still there, only difficulty is now it is not sorted on row number and column number. Whereas we have said in the previous lecture itself that the sparse representation should be preferably sorted on row, and if row number is same, then it should be sorted on column. Whereas it is other way around, it is sorted on column, and when column number is same, it is sorted on row. What could be the option? I know that there are in all 4 columns. This information I know. So when I try to copy, first it will be 4, 3, 6. This so I can always make. Isme koi problem nahi. Then I will look for this column value to be equal to 0 from top to bottom. And whenever I get column 0 value, I will copy it, but I will copy that column number as row number. So I get only one, it is 0 to 10. So ये हो गया. Then I will search for column number 1 from top to bottom. 1, 1, 4, 1, 2, 5. Then I will search for column number 2, 2, 0, 3. And then I will search for column number 3, 3, 0, minus 1, 3, 1, 7. So this is not the one which we are looking for. We should be doing this. The method that I am showing you right now is called as the simple transpose. And we'll say that transpose of SP1 to be stored in SP2. This is the job. SP2 or SP3 or SP4, whatever. I will initialize K2 to 1, of course K1 also to 1, and I will say while K1 is less than or equal to SP1 square bracket 0 dot val. Let us think. No. ऐसा नहीं कर सकते. एक सेकंड ना. एक second. We are going to store values in SP2 from position 1. That is true. Secondly, I will have to go through all the elements, but every time searching for a particular column number. First column number 0 search karna hai, फिर column number 1. So let us first write a loop for column number, that is for j equal to 0, j less than, how many columns are there? SP1 square bracket 0 dot col, these many columns, j plus plus. So initially j is 0, so I should be searching for j equal to 0 throughout SP1 from position 1 to position SP1 square bracket 0 dot val. Okay. So it will be again a for loop for K1 equal to 1, K1 less than or equal to SP1 square bracket 0 dot val, K1 plus plus. So I am picking up one column number, that is 0, and checking throughout this array for that column number. So I will have to put a check. Okay, when if SP1 square bracket K1 dot column, if it is equal to j, like initially j is 0, so I am searching for 0, 0, 0, and whenever it matches, that should be copied to SP2, whereas row number should go as column number and column number should go as row number. So it will be SP2 square bracket K2 dot row equal to, जरूरत नहीं है, j लिखो, SP2 square bracket K2 dot column will be SP1 square bracket K1 dot row, column number as row number and row number as column number, value as value, SP2 square bracket K2 dot val equal to SP1 square bracket K1 dot val and increment K2, K1 तो हो ही रहा है increment. So for j equal to 0 it will go through fully and will copy only column 0 elements. Then j equal to 1 it will again traverse, j equal to 2 it will again traverse. And then I am required to copy this 436, which will be done outside. So this is the loop, and then finally you will say sp2 square bracket 0 dot column equal to sp1 square bracket 0 dot row. sp2 square bracket 0 dot row equal to sp1 square bracket 0 dot column, and sp2 square bracket 0 dot val equal to sp1 square bracket 0 dot val, and the transpose will be true. Complexity, how many comparisons are taking place? Number of columns into the number of elements, these many times the comparison is taking place. Got it? That means whenever we go for something called as fast transpose afterwards, that should result in less complexity than this. Complexity of this, number of comparisons, number of conditions checked, you can say, will be sp1 square bracket 0 dot column into sp1 square bracket 0 dot val. एवढा comparison होता. Loop inside a loop. Outer loop is executed sp1 square bracket 0 dot column times, and every time inner loop is executed sp1 square bracket 0 dot val. Okay, so these many comparisons and twice of it, because every time inside you have one equal to comparison. This is what we say as complexity. You will have to prove afterwards that whatever we are proposing as fast transpose should have lesser comparisons than this. In this case, it will go for in all 24 comparisons before it actually reaches the final answer. Right? Make a note, show both the examples. What will you call this as? What will be the complexity of this transpose? नहीं, सॉर्ट नहीं करना, ऐसे ही अगर आउटपुट चाहिए तो व्हाट इज द कॉम्प्लेक्सिटी? वैल्यू टाइम्स 6 कंपैरिजन इतने हुए ना, केवल यहां से यहां तक एक ही लूप में हुआ, वो स्वैपिंग के लिए तो कॉम्प्लेक्सिटी नहीं होती. कंडीशंस चेक्ड शुड बी द कॉम्प्लेक्सिटी. So you have simply interchanged all the elements in this array. Result is not sorted, so we are not using this representation. We are going for something else so that the result will be sorted and it has the complexity of its own. Anybody has any difficulty in understanding this? Fast transpose. I am changing the example slightly. So that the understanding so I am adding one more row to it, making it 4 by 4. Now I will be using one more array called as, say, count, and this array will be initialized to 0. It's an array of counters. I will start with saying that for, as usual, k1 is equal to 1, k1 less than or equal to sp1 square bracket 0 dot val k1 plus plus. What am I doing here? I am going through this sparse matrix from top to bottom. Of course, I have added 2 elements, so there will be 8 values. From top to bottom. Every time I will pick up the column number and increment the corresponding counter. I will be saying it this way: CNT of CNT square bracket sp1 square bracket k1 dot column plus plus. So initially k1 is 1. So what is sp1 square bracket k1 dot column 2? So counter 2 will be incremental. This is 0, 1, 2, 3. This will become 1. CNT of 2 plus plus. Then it is 3. So CNT of 3 plus plus. Then it is 1. CNT of 1 plus plus. Then it is 3. CNT of 3 plus plus. Then it is 0. CNT of 0 plus plus. Then it is 1. CNT of 1 plus plus. Again 1. CNT of 1 plus plus. Then 2. CNT of 2 plus plus. Got it? What we have done, we have counted as how many elements are there in column 0, how many elements are there in column 1, how many elements are there in 2, and how many are in 3. From here, I will come to know that if there is only one element of column number 0, then it will be always going as the row number in the resultant. I can actually demark sp2 only one element in column number 0. So only one position will be required for column number 0. 3 for column 1. 3 for column 1. 2 for column 2. And 2 for column 2. Column 3. Can I come to know the start position of each column number? This is from 1. This is starting. This was position 1, position 2, 3, 4, 5, 6, 7, 8. So column 0 element is at position 1. Column 2 elements are starting from position 2. Actually, this is the demarcation from 2. Then column 2 are starting from 5. And column 3 are starting from 7. Can these values be obtained from CNT? Yes. So I can have position as one more array, which will be, see how I calculate it. I start with 1. 1 plus this value should give me this. 2. 2 plus this value should give me this. 5. 5 plus this value should give me this. 7. 7 plus this value will give me this. 9. Of course, if the next column would have been there, it will be at column number, row number 9 से शुरू होता था वो, position 9. Can you do this calculation going for a position array? We can, because we can write it like for j equal to, okay, we'll just say position of 0 equal to 1, and for j equal to 1, j less than what? sp1 square bracket k1 dot col. We are going for number of columns, j plus plus. Why this is 4? Because there are 4 columns. Has nothing to do with how many values are there in sp1. And then every time position of j, this value, because we are starting from 1, will depend on the previous value in the position and previous value in the counter. Addition of those two. So it will be position of j minus 1 plus CNT of j minus 1. To find out this value, you are adding the previous position values in both the arrays. So you will get this. Then when you go to this position, you are again adding the previous 2 position values in position and counter. Position, previous 2 index values we can say. Yeah. Values at the previous positions. And I will get this position. Now what do? I pick up the element from here. 0, 2. From 2, column number 2, I will check what is the start position, 5. So I will pick this value and straight away store it at position 5 as 2, 0, 3. And this position is consumed, I make it 6. So this element has been converted. 0, 3 minus 1, column number 3, check the position at position 3 here, 7. So write this element at position 7, 3, 0, minus 1 and increment it, 8. So this is over. 1, 1, 4, 1, that is at 2. So it is 1, 1, 4, increment it, 3. 1, 3, 7 at 8. So it will be written as 3, 1, 7, increment it, 9. 2, 0, 10. It will be written as 0 to 10 at position 1. 2, 1, 5 at position 3, 1, 2, 5. 3, 1, 16 at position 4, 1, 3, 16. And 2, 3, 3, 2, 4 at position 6, 2, 3, 4. And you get the transpose, which is again in the sorted manner. But how many times am I going through this array? Once. Actually twice. एक बार ये काउंटर के लिए और एक बार एलिमेंट्स प्लेस करने के लिए. Compared to the previous times, which was 8 into 4 times. मतलब 4 times we were going through this. So as the number of columns increase, it will be those many times. Now irrespective of how many columns you have, you will be going through this only twice. एक बार काउंटर कैलकुलेट करने के लिए एंड एक बार एलिमेंट यहाँ से उठा के प्लेस करने के लिए. लास्ट 3 लाइन्स विल रिमेन द सेम, रो नंबर को कॉलम नंबर करके और वैल्यूज नॉन जीरो वैल्यूज कॉपी करने के लिए. आई वॉन्ट यू टू डू दिस एक्सरसाइज. बिना समझे अगर लिख के लोगे तो कोई फायदा नहीं. जस्ट गो थ्रू एज हाउ आई हैव प्लेस्ड द एलिमेंट्स. Okay, then we will complete the code. This was the first part. One more loop and it will be through. Fast transpose. It should go up to 3 only. It is calculating one value extra, which I have also indicated, but it is not used. Or it does not. It does not. It calculates only up to 7. ये calculate भी नहीं होता. Less than or equal to लिखा तो वो calculate होगा, but that is not used. It is possible to do this job only in single array also. मतलब मैंने एक array count का लिया and one array of position. You can use only one array and do it. It is possible. पहले ये calculate करके थोड़ा सा shifting करके you can manipulate into that only, which is possible. But put it this way, this will be acceptable and you can easily understand the difference also. So how do I write it now? It will be for k1 equal to 1, k1 less than or equal to sp1 square bracket 0 dot val k1 plus plus, because I will have to go through this sparse matrix fully from top to bottom once. Now I will be saying, which was actually not required, I can write it in slightly different manner, but K2 will be the value at array POS for that particular column. So like sp1 square bracket k1 dot call is 2 and position of 2 initially is 2. That will be k2, that is position in sp2. That is what you have done, no? You have picked up this 2 0 and placed it at position 2 in sp2. sp2 का position हमेशा k2 से दिखाते हैं हम. So I have picked up the particular column number. For that column number, what is the position that I have picked up from the array? That is K2. So at position K2, I will have to copy. So sp2 K2 dot row equal to sp1 K1 dot column. sp2 K2 dot column equal to sp1 K1 dot row. And sp2 k2 dot val equal to sp1 k1 dot val. और जो हमने पोजीशन उठाई थी, that should be incremented. Don't increment k2, that is of no use. You will have to make change in array position. So you will have to say POS sp1 square bracket k1 dot call plus plus will do that job of transferring the values, and at the end the same 3 statements 0 के लिए, वो तो 3 रहेंगे, उनको तो कुछ नहीं कर सकते. setting the overall size. That will complete the fast transpose. नहीं हो, जीरो में डायरेक्टली जीरोथ वैल्यू, ऑल जीरो. Last three statements will be sp1 square bracket 0 dot row 2, sp2 square bracket 0 dot row equal to sp1 square bracket 0 dot call, sp2 square bracket 0 dot call equal to sp1 square bracket 0 dot row, and sp2 square bracket 0 dot val is sp1 square bracket 0 dot val. क्योंकि ट्रांसपोज में नॉन जीरो वैल्यूज will remain the same, has nothing to do with array POS or CNT. Effectively, the algorithm has given us the transpose by scanning the given sparse matrix only twice, is independent of the number of columns of the original matrix. This is the acceptable fact that you will have to scan it once or twice. एक बार पोजीशंस कैलकुलेट करने के लिए और एक बार वैल्यूज ट्रांसफर करने के लिए. Now, how many of you have the assignment on multiplication of sparse? Good. And I believe that they may not have mentioned anything related to it. काय रे सांगितलं कसं करायचं काय? हा मग तेच म्हणतो मी. करा सांगितलं असेल, कसं नसेल. अरे एक्झाम्पल कशाचंही असेल त्याचा नाही प्रश्न, करायचं कसं. Why I have asked this? Because we will be going through the reverse way, that is I will multiply two sparse matrices but will generate the normal matrix as a multiplication. Because what happens is this multiplication, again I am going on the assumption that you know how to multiply two matrices. Because the matrix multiplication, like matrix A having m1 rows n1 columns, when is multiplied by matrix B having m2 rows n2 columns, then first condition is number of columns of first one should be equal to number of rows of second. The resultant matrix C will have n1 rows, n2 columns. Printing mistake. M1 rows, n2 columns. Right? Can you just tell me how many multiplications are done in this particular process? It is a single matrix multiplication, but how many values get multiplied? One, two, three, four. If there are 4 columns, multiplying 1, 2, 3, 4 elements, first row, first column will give us one value in the resultant. Huh? So how many values are there in the resultant? M1 into N2 values. These many values. For each value, how many multiplications are taking place? N1 or M2. That is one and the same value. So for each position there will be into N1. These many multiplications are taking place. How many additions are taking place? For each position, when this is 4 into 4, there will be 3 additions. So number of additions which will take place will be M1 into N2, these many elements, into N1 minus 1 additions. Unless I do this job fully for one element, I will never come to know whether the resultant value is 0 or not. Because if it is 0, then it should not go to the sparse. And at a time in sparse, you can get this particular condition to be true. Like you have 0, 2 element in the first sparse notation form, and corresponding element some 2, 1 element. Values could be anything. There could be 2, 4 element. See, here it is row number 0 element, column number 2. So row 0, column 2. This element will multiply all row 2 elements over here. Not ये 2 position है, यहाँ का value will multiply all row number 2 elements in the second. So this 0, 2 when multiplies this will give me 0, 1 element. Not fully, part of it. You are having so many multiplications and these terms are to be added. You will be having N1 multiplications, N1 minus 1 additions to form one element. 0, 2 multiplying 2, 1 will give me part of 0, 1. 0, 2 element multiplying 2, 4 will give me part of 0, 4. I can have something like 0, 3 multiplying 3, 1 will again give me the second part of 0, 1. So whenever you multiply, sparse में यहाँ का एक वैल्यू लेके यहाँ पे मल्टीप्लाई करते गए अगर हम, तो I will have to check whether column number over here matches with row number over here, like the overall check that I have. Result will be the position in the resultant sparse, which will be 0, 1, then next time it will be 0, 4, then it will be again 0, 1, that should be added to the previous one. So if you just go on multiplying, you will require all the positions, because every time you will be getting one part. So the sparse that you are going to generate will have almost all the positions. That will be complicated. Instead of that, I multiply and I store it in array C at position 0, 1. Next time I add this particular multiplication, 0, 3 multiplying 3, 1 at 0, 1 position in that C. So I generate C, which is a standard matrix, and I convert it to sparse. And convert to sparse matrix, we have the function. Because instead of using so many counters or so many positions, because at a time you are not going to get any single element fully. If you try to go for checking row number 0, column number 1, all multiplications, then it will be highly complicated. As I have pointed out last time, that instead of going for, whenever we check the efficiency of the code, it will be always dependent on either the efficiency memory wise or speed wise. When we say that the program is complex or complexity is high, that means the number of comparisons are more. I am trying to reduce the number of comparisons by making use of memory, which will be the sparse, which will be the standard matrix. And as our teachers unfortunately are not telling us as how to do it, till that time such a thing should be acceptable. Will be accepted, because even if you write it, they won't understand it. Okay, as it is, whatever we are writing, like I will be showing you the code, in that code you will not see anything like C of IJ, because it will go as C of sp1 k1 dot row, second bracket में sp2 k2 dot column. So when anybody reads the code, it will be every line having sp into it, which was our sp archetype. So it is hardly possible that any teacher can point out that you are using a standard array and then convert to sparse is a function call. It will run, they will sign the journal. Okay, even in the exam you do it like this, nobody will object. Okay, if objection is to be raised, it will be raised by the internal only. But then obviously we will be asking them how to do it. Other option, I have told you that I can directly generate a sparse, but it will have all the elements and then I will have to compress it. See, if I use sparse of having m1 rows and n2 columns, then it will be having m1 into n2 elements, and that size will be quite higher than the standard matrix, क्योंकि उसमें row number और column number सभी के stored होंगे. So memory wise this is also efficient, but multiplication में कुछ और trick नहीं play कर सकते. That's not possible.
So what if we have two matrices? We take transpose of one matrix, as you are taking for the first transpose. You will know the position number where the elements are changing. And accordingly, we just check whether the element in the first matrix, the row and the column, is equal to the row and column of the same next.
ऐसा multiply नहीं होता ना निखिल.
So we are just making the whole change, sir. We are taking it transpose, sir.
So what?
So once we are multiplying it, if the element is not present in the second row, second part, directly it is 0, it is out of the question.
क्यों?
So how can you multiply 0 with some value? It is going to be 0 only, sir.
But we are not multiplying by 0 even in this case.
So if there is a 0 at some column place and there is a value at row place in the first matrix and the second matrix, then the multiplication will be 0 at that particular part.
That will be one part is 0.
One part, that's what I'm talking about, one part.
मग त्याचा ओव्हरऑल तुला काहीच उपयोग होत नाही.
सर होतं ना सर, प्रत्येक एलिमेंट मल्टिप्लाय करत असतं आणि नंतर त्याच्यात एकच ऍड करतो ना सर.
कुठे ऍड करणार एकत्र? तेवढ्या पोझिशन्स तर पाहिजे तुझ्याकडे.
सर आपण मल्टिप्लाय करताना इफ आणि एल्स लूप वापरून खाली ऍड करतो ना सर.
इफ आणि एल्सचा तर लूप नसतो पहिली गोष्ट.
फॉर लूप वापरून इफ एल्स कंडिशन देऊन ऍड करतो ना सर.
नाही रे, कसं करणार सांग? तुला जर का प्रत्येक वेळेला एकच पार्ट 0 आहे का नॉन 0 आहे कळतंय, तर ओव्हरऑल त्या सगळ्या पार्टची ऍडिशन 0 आहे का नॉन 0 आहे कसं कळणार? जोपर्यंत सगळे एलिमेंट्स मिळत नाहीत तोपर्यंत. तू ट्रान्सपोज घे, आणखी काही कर. तू ट्रान्सपोज घेतलास काय नाही घेतलास काय फरक पडणार आहे? शेवटी मी याचा ट्रान्सपोज घेतला तर हा होईल, याचा ट्रान्सपोज घेतला 2 0, काय फरक पडला माझ्याच्यात? मी इथला 2 0 आणि इथला 2 0 कम्पेअरच करत नाहीये. मला इथला 2 त्यातल्या 2 शी कुठे मॅच होतोय तो, आणि इकडचा रो नंबर तिकडचा कॉलम नंबर हा एक पार्ट होतो रिझल्टचा. मग एक पार्ट होतो तो. पण त्याचा उपयोग काय?
आपल्याला हे कळलं की पहिला रो किंवा पहिला एलिमेंट आपल्याला कुठपासून कुठपर्यंत ऍड करायचं आहे, म्हणजे ते मल्टिप्लिकेशन करून तेवढे ऍडिशन करून ते फर्स्ट एलिमेंट मिळायचं.
मी तेच सांगतोय, हे सगळं शक्य आहे, पण कॉम्प्लेक्सिटी किती होईल हाय ते काय तेवढ्या भागात नाहीये. परत तो 0 1 एलिमेंट पुढनंही मिळतोच. पूर्णच्या पूर्ण मॅट्रिक्स तितक्या वेळा स्कॅन करायला लागतो m1 into n2 टाइम्स. दॅट इज नॉट पॉसिबल. Resultant matrix is going to have number of rows of the first matrix and number of columns of the second. This is the only place where I can actually see the two-dimensional array, because I will have to initialize all the elements to 0 and afterwards I will be adding values to it. Once all of them are set to 0, then I will pick up from sparse one by one, sparse one by one each element. For each element, I will check in the second sparse where the column number of the first one is matching with the row number of the second. If yes, add the corresponding elements and store it at 0, 1 position. Add it in C of 0, 1 position, like that. So it will be for K1 equal to 1, K1 less than or equal to sp1 square bracket 0 dot val K1 plus plus. For K2 equal to 1, K2 less than or equal to sp2 square bracket 0 dot val K2 plus plus. So one element in sp1 now is to be compared with all the elements in sp2 for the condition that if sp1 square bracket k1 dot col, if it is equal to sp2 square bracket k2 dot row, यहाँ का कॉलम नंबर अगर यहाँ के रो नंबर से मैच होता है, in that case the corresponding product should be added to C of sp1 square bracket k1 dot row. This is row number. Column number will be sp2 square bracket k2 dot column. This is the position in C of array C. Like here it is 0, 1 position. And in that 0, 1 position, what should I add? The product of these two values. यहाँ पे अगर 5 है और यहाँ पे 7 है, so 35 will be added at position 0, 1 in matrix C. So instead of again writing it again, I will write it plus equal to sp1 square bracket k1 dot val into sp2 square bracket k2 dot val. काय के लिए कर्ली ब्रैकेट भी चाहिए? एक ही तो काम करना है. हाँ, k plus equal to j is nothing but k equal to k plus j. I will have to add it to C of ij. So परत हे एवढं सगळं टाइप करण्यापेक्षा प्लस इक्वल टू लिहा. This will generate C. This will generate matrix C, and then call convert to sparse, and it will be in sparse form. Easier, faster, even from the practical point of view. Of course, this entire thing should be done only on the condition that if sp1 square bracket 0 dot column is equal to sp2 square bracket 0 dot row, number of columns of first one equal to number of rows of second. That is a primary condition to multiply two matrices. Then you can do all this job. Okay, and now I will call convert to sparse. Parameters are C, comma, how many rows are there in C? How many rows are there in C? sp1 square bracket 0 dot row. And how many columns are there? sp2 square bracket 0 dot column. And हमने कुछ और भी लिखा था ना, this should go to sp3 comma, ऐसे आता है ना हमारा कॉल. This was AMN converted to sp3. So it is convert to sparse into bracket sp3 comma C comma sp1 square bracket 0 dot row comma sp2 square bracket 0 dot column. That's it. Done. Now sp3 will contain the multiplication. That's where our first topic, sparse matrix, will be over. Other than this, you don't have anything. We'll come back to it afterwards in the revision process, where these functions will be converted to pointer form after learning the pointers. We have not yet covered any part of pointers. So till that time, to do this assignment, it will run, and then we can easily change it to pointers by making some changes into it, not the entire code.